Hi Pre-Cal students. Today is the last lesson of Unit 2. We've had a short unit here. It's about composition of functions, okay? Which you probably don't know a whole lot about, but it's basically taking a function and plugging it into another function. But we'll show you how that works today. So here we go. All right. So this is lesson 4, which turns out is the last lesson of this unit. This is a really short unit after having pretty long unit to start the year, but lesson 2, 4 here, composition of functions. So, composition of functions is denoted by this little circle here. It's an open circle between the f and the g. And sometimes it's read f circle g of x is equal to f of g of x. We're going to take g of x and we're going to plug it into the x in the f function. Okay? Composition of the function f with the function g is f circle g of x, which equals f of g of x. The domain of f circle g of x is the set of all x in the domain of g, such that g of x is in the domain of f. Alright, so we have several problems we're going to work through here. Number 1, given f of x equals x plus 2 and g of x equals 4 minus x squared, find the following. First thing we want to do is f circle g of x. Okay, so I know that this means f of g of x. My g of x is 4 minus x squared. So what I'm going to do is I'm going to take 4 minus x squared and plug it into my f function for the x here. So I'm going to have 4 minus x squared for my x and then plus 2. This was x plus 2, so now it's 4 minus x squared plus 2. And then I simplify that. 2 plus 4 is 6. So I get 6 minus x squared. And there we go. There is f circle g of x. Alright? G circle f of x. So this time we're reversing it. So this means g of f of x. So that's g of x plus 2. This my f of x is x plus 2. So now I'm going to take the x plus 2 and plug it in for the x in the g function. So that's 4 minus x plus 2 squared. So I'm going to expand that. X plus 2 squared is x plus 2 times x plus 2. And if you FOIL that out, you're going to get x squared plus 4x plus 4. So now I'm going to distribute the minus sign out in front of the parentheses here and change all the signs inside the parentheses. 4 minus x squared minus 4x minus 4. And my 4 minus 4 will just end up canceling out. And my answer is negative x squared minus 4x. And that is the answer for g circle f of x. So I want you to notice here that f circle g of x gives us a totally different answer from g circle f of x. All right, those two functions. So what we're seeing here is that composition of functions is not commutative. In general, f circle g will not equal g circle f. Sometimes it does. It is possible that it will, but in general, that will not be a true statement. All right, last one, f circle g of negative 2. Okay. Well, we've already done f circle g of x, so this is simply f of g of negative 2. All right, instead of x here, I have negative 2. Well, we've already done f circle g, and we know it's going to be 6 minus x squared over here. Well, I'm just going to replace the x with negative 2. So I'm going to say 6 minus negative 2 squared. Negative 2 squared is going to be a positive 4, and 6 minus 4 equals 2. So there you go. All right. We could also have done that by taking negative 2. We could have done g of negative 2. So if I plug in negative 2 into g, 4 minus negative 2 squared is 4 minus 4 equals 0. And then taken that answer and put it into f. f of 0 is equal to 0 plus 2. And we could have gotten the 2 that way as well. Okay? Let's look at number 2. given f of x equals x squared minus 9, and g of x equals the square root of 9 minus x squared, find the composition of f circle g of x, then find the domain of that, f circle g of x. All right, so f circle g of x is f of g of x. I think it's, I always write that down. Notice the f comes first, then the g, just like on both sides here. But I find it easier to follow if I write everything down. G of x is my square root of 9 minus x squared. So I'm going to take that and plug it into f. So where the x is, I'm going to put square root of 9 minus x squared, and then I'm going to square that and subtract 9. And so what I get is square and square root are simply going to cancel. 9 minus x squared minus 9. 9 minus 9 cancels, and I end up with negative x squared. That is f circle g of x. So what's the domain of this thing? Normally we would look at this and we'd say, well, the domain's going to be all real numbers. But notice the domain of g was not all real numbers. Okay? Domain here was is limited. My domain for g of x is only from positive 3 to negative 3. All right, domain of g is only from positive 3 to negative 3, and the output of that is only from 0 to 3. Okay? So looking back up above here, it says the domain of f circle g of x is the set of all x in the domain of g such that g of x is then the domain of f. Alright, well I don't have a problem with f because f is going to be x squared minus 9. That has the domain of all real numbers. So I don't have any problems with that. But my g of x is going to be somewhat limited. Alright, so all x in the domain of g such that g of x, so the output of this is fine, but the domain of this is only from negative 3 to positive 3. So my domain of my function here is only going to be from negative 3 to positive 3. Alright, so if you graph this, what you're looking at is negative x squared, but it's only going from negative 3 to positive 3, so it's not going to keep on going, to this upside down parabola, but it's only going from negative 3 to positive 3, and then it stops. It doesn't keep on going down forever. Okay? Alright. Oops, you couldn't even see that. Sorry about that. My domain was negative 3 to positive 3 inclusive, and then the graph of that would be limited from negative 3 to positive 3. Alright, so let's go to the back. Don't you just love the green paper, by the way? Sorry I didn't point that out before. Alright, so now number 3, we're going to do decomposition. Okay, we're going to decompose our h of x into two functions here. Right, the function h of x equals 1 over x minus 2 squared as a composition of two functions. Okay, so here's how it works. What I want, I'm going to say h of x equals f of g of x. Okay, so I want some function g of x that I can plug into f, and then my output is going to be h, which I already know. H is my output here. So what I'm looking is breaking this down into parts, kind of. All right? So the way I can do this, I could say, for example, f of x equals 1 over x. F of x equals 1 over x. Well then g of x, if g of x is going to plug in to this x, and I want this to be the outcome, then g of x would have to be x minus 2 squared. So this is one way we could decompose h into two functions. A separate way that I could do it, I could say, alright, f of x is 1 over x squared. So now I've got something here and then it's squared already. So in this case, g of x would simply be x minus 2. So that when I took x minus 2 and I plugged it in for the x here, my output would be 1 over x minus 2 squared. Alright, so here's two separate good answers, either one of which would work. And there's probably more, but those are the first two that pop into my mind. Okay? So that's how decomposition works. Let's look at number 4. Use the graph to find each of the following. So I've got f of g of 6 and g of f of 4. So here's what we're going to do. We're going to start, and you can see I've got both functions here. My f function is this one. My g function goes up in a straight line, and then kind of all is made of lots of line segments here, whereas f is curvy. So for part A, f of g of 6, f of g of 6. Well, I'm going to start by focusing on g of 6. So I'm going to go to where x equals 6, and then I'm going to go to the g function, and the g function is this one with the straight lines. So that would be g of 6 equals -1, because it's the g graph at 6 equals -1. So now I've got f of -1. So I go to -1 on the x-axis and go to the f graph. So here's -1 for the x, and I'm going to go my f. This is my f function here. So f would be equal to -2 at that point. So that is our answer is -2. If you want to pause the video, see if you can figure out part B, and then come back and check, you can do that. And we'll continue working here. G of f of 4. So I'm going to start with f of 4. So I go to where x equals 4, and now I'm going to the f function. So here's where x equals 4. This is my g function. Here's my f function up here, and it's equal to 3. So I'm going to say 3. So now I'm going to go to where x equals 3 here and go to my g function. And actually, it doesn't really matter which one I go to at 3 because they're the same. They're both equal to 2 there. So my answer is +2. And so that is how we use a graph to do composition of functions, to evaluate a composition of function there. All right. Last problem. So here's a real world situation where we might want to use composition of functions. And we're going to have tomorrow, you're going to have another application sort of thing. The number n of bacteria in a refrigerated food is given by n of t is equal to 20t squared minus 80t plus 500, where t is between 2 and 14. T is the temperature of the food in degrees Celsius. So we're talking about between 2 and 14 degrees Celsius. When the food is removed from refrigeration, the temperature of the food is given by t of t equals 4t plus 2, where little t here is between 0 and 3, time in hours. All right? So we have bacteria is given by this first function, and then the temperature is given by the second function. So A says find the composition n of t, interpret its meaning in context. So let's start with that. A says n of t of t. So t of t is the second function here. It is 4t plus 2. So I'm going to take this 4t plus 2 and I'm going to plug it in to my n function up here. Alright, so so I'm going to put in 4t, actually, sorry about that, I'm going to put 20 times 4t plus 2 squared minus 80 times 4t plus 2 plus 500. Okay?
The answer to 42 plus 2 plus 5.
Sorry about that. Phone kicking on. Alright, so first thing I'm going to do is I'm going to square this thing. Because please excuse my dear Aunt Sally says, take care of your parentheses first. So I got, and then exponents, so I'm going to square first before I start multiplying out here. So 4t plus 2 squared is 16t squared. 4 times 2 times 2 would be 8 times 2 is 16t. Plus 2 squared is 4. Minus 80 times 4t plus 2 plus 500. So now I'm going to distribute. 20 times 16 is 320t squared. Is that right? I think that's right. 20 times 16 is 320t. 20 times 4 is 80. Minus 80 times 4 is 320t. 80 times 2 is 160. Plus 500. We're going to gather like terms. And so I've got 320t squared. That's my only t squared here. I've got plus 320 and minus 320t. So those will just cancel. And then I've got 80, positive 80, positive 500, and a negative 160. So that's The two positives are positive 580, and I'm going to subtract 160 from that. So I think that's 420. So plus 420. And so that is our answer here. And it says, interpret its meaning in context. Notice little t stands for the time in hours. But what I'm finding is the number of bacteria. So what I did was, you know, the little t, the t function here, the t function up above is giving me temperature. The n function is giving me number of bacteria. All right, so now, but the temperature was on time and the number of bacteria was on temperature. So now I've got the number, this is the number of bacteria based on time. All right, number of bacteria based on time. So this is telling me number of bacteria based on amount of time. Okay? And then B says, find the time when the bacterial count reaches 2,000. So now we're just going to solve this. I'm going to say 2,000 is my number of bacteria. And I'm going to say equals 320 t squared plus 420. So I'm going to subtract 420 from both sides. 2,000 minus 420 is 1,580. It's equal to 320 over t squared. So t squared equals 1,580 over 320. Let's see how that's going to... and my calculator's telling me this is 4.9375. And so now I'm just going to take the square root. Normally I would say take positive or negative root, but negative root doesn't make any sense here. So I only need the positive root. So the square root of 4.9375 is approximately 2.222, and we're talking about hours here. So in 2 hours, you know, close to 2 hours, 15 minutes, then we will have 2,000 bacteria in this refrigerated food, or the food that we took out of the refrigerator. Okay? All right, that is it for today. I hope things are going well with you, and we will have, like I said, we'll have the application sort of thing tomorrow. Bye-bye.